Welcome back to MLearners. My name is Santosh, and the topic for today, as you already know, which is what is machine learning. So this topic is very crucial before starting on with any further topic in the machine learning domain. Okay, so let us see what is machine learning. Okay, before starting with what is machine learning, let us see why machine learning exists in the first place. Right, that is very much important to know before understanding what behind any topic. Right, so let's try to select some color. Okay, so why machine learning? So before machine learning, most tasks were operated on a rule-based approach, right? So we have to understand what is rule-based approach and how that differs with something called as smart approach or intelligent-based approach, which machine learning try to solve, right? So a rule-based approach here, let's give an example. Let's take an example of a chatbot assistant. Okay, this is a chatbot, right? So let's compare rule-based chatbot with AI-powered chatbot. Okay. So what rule-based chatbot is doing, as this is the greeting message it prompted. How can I help you? So this is the greeting message prompted by a rule-based bot with the three options, right? Order status, cancel order, and return request. So these are the three options along with the greeting prompt which rule-based bot want us to or user to select from. Right, but what user have did, he instead of selecting from these three options, what he did, he tried to give a query by saying when will he receive the refund, right? So since this is a rule-based chatbot, it prompted again with, I'm sorry, but I don't understand your request. Please select from the following options, and again it prompted with the same three options. So what it is trying to do, it is trying to give user these options and expecting the user to select from these three options only, right? Which is order status, cancel order, and return request, right? So that means it is not understanding what user is asking. So this is not understanding any natural or general query, right? So what we can understand by this, so it is predefined to only answer certain query given by the user. That is, it has prompted with three options. It is here in this case only defined to respond to only these three options. So apart from these three options, whatever the user will ask, it will not able to answer it. So that is why it will go to something called as fallback response. Okay, so this is a predefined response for all kind of bots. Okay, this will fall back to this kind of fallback response by saying I'm sorry. Okay, so we can understand, right? So the rule-based chatbot is basically responding to those three options only. We can say it is a systematic and predefined approach. Like if condition happens, then do this, else do something else. So we can clearly see that this is a predefined approach where some programmer has coded it, right, in this manner. So if something apart from the conditions it sees, then it will naturally doesn't respond and fall back to this fallback response. So that is how the rule-based chatbot actually designed. So similarly all the rule-based systems are designed in the same way. We can say most programmatically, where the answer is already known and it doesn't really have active learning from data, right? It will only develop if a human try to include more conditions. Otherwise it will not learn on the go on its own, right? So this is the rule-based approach of chatbot, designing a chatbot. Let's see how AI powered chatbot is responding to the same query. So again, here when will I receive my refund? Same question asked by the user, but here you can see there are no predefined set of options it has given. So let's see how it responded. So it responded with, let me check. Your refund is being processed. You will receive the refund back on your original form of payment in the next 3 to 5 business days. So that is it is acting like a human here, right? So that is why it can able to understand natural query, which is natural language. So it can able to respond to any general query asked by the user, and it tried to respond in the human way possible, right? So that is the difference between a rule based and AI powered chatbot. So it can able to understand the data and do the action based on the data itself. So there is no predefined rules over here. So AI powered chatbot can only work on the ML or AI models behind it, or it can also take the advantage of rule based approach. So it can be both, but a rule based approach is just a rule based approach. That means it is only conditioned based system, right? So I hope you got the difference between a rule based and a AI powered chatbot. Okay, let's move on to one more example. Okay, let's say if you want to design a self-driving car, okay, but without any AI power or machine learning approach, just you have to use rule based approach. So what you will do, let's say a task of, let's say car is running, a car is already driving, you have to make the car to stop. So the car which is already driving, you have to make the car to stop on its own. So how we will do that on a rule based approach? You will form certain conditions, right? You will include all the conditions where a running car should stop, right? Let's say one condition which, if a pedestrian comes, then you have to stop the car, right? So if pedestrian comes, you have to stop the car in between. So if a pedestrian comes in between the road, then you have to stop that car. And other condition, if red light appears or red signal appears, again you have to stop the car, right? So likewise, there will be n number of conditions you have to stop the car. One more condition is, if there is some blockage on the road, you have to again stop the car, right? So already we have coded 3 conditions. Likewise, there will be n number of conditions or n number of situations where you have to stop the car, correct? So you can't code all the conditions, or it's very hard to code technically to build a self-driving car on its own. It's just one problem we are solving. Just a car is running and we have to stop, right? That is one problem we are trying to solve using a rule-based approach, right? Based on conditions, which we can solve it, but it will take lot of iterations and improvements, and it will be very hard to build in this approach, right? So we can simply say, when the complexity of task increases, we have to have intelligent systems. So what I mean by complexity? The complexity is just we saw an example of self-driving car, that is a complex system. So when the system which we can't predict what will happen in the future, we have to go to a system called machine learning, or any system powered by artificial intelligence. So that system should on itself act based on the situations it is going through. So that is why we moved to machine learning from a rule-based approach. Okay, so we have rule-based approaches for most of the tasks, but whenever the task at hand is very complex, the rule-based approach or programmatical approach will not able to tackle that problem, right? So now that we understood why behind machine learning, why machine learning exists, now let's move on to what is machine learning and understand it in more clearer way. Okay, so machine learning is a way to make a system. So machine here refers to system or computer to learn, to predict, analyze, generate from the data. So once it is given a data, it will try to learn from the data to achieve one of, or to do one of these tasks: predict, analyze, or generate, right? These are different tasks where machine learning is capable to work or to do. Okay, so example of any machine learning system, so as we already saw, so self-driving car is one of the example of a machine learning system, and another example is YouTube recommendation system. So you have seen, right, whenever you open a YouTube, you will see lot of set of videos recommended on your home screen or a home page, right? So that recommendation works on something called as recommendation systems. So that is a machine learning system. Okay, and whenever you open some video in a YouTube, you will see some suggestions of the video, right? Different videos related to the video which is already running. So that is also a recommendation system. Okay, so and another example is ChatGPT, which is also a intelligent system built on a machine learning or artificial intelligence, right? So moving on, so let us take an example of a machine learning problem to understand how machines what is machine learning and how machine learning will solve that problem. Okay, so the problem is called MNIST handwritten image. What is this? What are those images? So the images are handwritten numbers. Okay, so 5 is one handwritten number, 0, 4. So this data set will consists of these images and also labels. So the labels will not be printed on the images. So this is just a representation they have given, but so just you'll have the number, like I'll show you one second. So this is the number. So that is how each image is represented. So handwritten images. So the problem is, what is the problem? So that is called problem statement. So we have to know what is the problem statement of this task. So given the images of handwritten digits here, 5, 0, 4, whatever. So 0 to 9 are the handwritten images. So we have to, given images of handwritten digits, we have to classify what is that image, right? So since we are trying to classify, like this is a 5, right? So given 5, we have to label it as 5, right? So since we are classifying given an image, right, we have to label it, right? So here it is 0 to 9. So total 10 possibilities, right? So we have to label or select what is the image belongs to. So that is called classification. So since we have more than 2, if any problem has more than 2 labels, it comes under multi-class classification. So these are some of the images, handwritten images. So actually these we have 70,000 such images in the dataset. So the dataset is very large. So this is called combinedly all the images or any data for the machine learning, we call it as a data set, right? We call it what is the data set size, right? Here the size is 70,000 images, right? So it is represented in this form, right? Any given data set in machine learning is represented using D, and D consists of set of so it should be unique values, set of X and Y pairs. So what is X and what is Y? Let's see. So X here becomes an image, like let's say the first image itself, which is image, handwritten image of 5. So and the Y becomes the label of, that is label which is 5. So this is an image and this is the corresponding Y, we call it Y, and this is X. So these are this is the representation X and Y's. So for the first image it will be X1 Y1, For the second image, which is 0, it will be x2, y2, and so on until xn, yn. So n here becomes 70,000. Likewise, we have combinations of x and y's, right? So you understood the problem statement, right? Given a images of handwritten digits, we have to classify what that image belongs to, right? So that is the problem. So now let's see how humans will approach this problem, right? How humans will approach this problem. So what we will do, we will open that image and visually try to map it to corresponding label based on the similarity, right? So now we will open this image 5, right? What we will do, we will try to see whether it is 0 or whether it is 1, whether it is 2, whether it is 4, likewise, right? Whether it is 5, and likewise till 9, right? So we will see all possibilities, right? And we will try to map it based on the similarity, right? So this 5, handwritten 5, is similar to this 5, right? And it is not similar to 0. So that means we will reject this. We will reject 1 also, right? But we will try to give the label which is most similar, which is 5 here. So likewise we will solve, right? We will open the image, visually try to map it to corresponding label based on the similarity, right? So we will compare the image with all the labels and try to do trial and error, right? So this is a trial and error approach. So we'll go with 0, no, it is not possible. We'll go with 1, then we will say it is not possible, right? It is not similar. We will go with 2, and likewise we'll go until 9, and we will try to do a similar trial and error based on similarity, visual similarity, right? That's how we will try to solve. It is a visual approach, we can say. So this is one approach. Or we can say we will just open it and just say, okay, is the label, we will say the number is 5 directly, right? Due to prior knowledge, right? Since we have the knowledge of number system, we can directly say, okay, that number or that image belongs to 5, right? We will only do that when we have prior knowledge of any given task. Without prior knowledge, we can't do that, right? So that is why we are going with the first approach, where when we don't have prior knowledge of numbers, we will do the similarity based approach, correct? So this is how humans will tackle it, right? Visually. So both in case we will try to open and see, right? That is a visual approach. Now, so how machines will solve this? Okay. Before that, let us frame this in ML terms, okay, like a small architecture. So given an image, in case of MNIST, it's an image, right? Given an input image to ML model, okay. The task of ML model is to predict the label or a number in the image, right? So that is the output. So this is how the system is, like, given a input data to machine learning model, it should able to predict or classify the corresponding label. So this is the ML architecture. So here we will not learn any ML model or any ML algorithm. We will try to approach this problem in a machine learning way, okay, and try to approach this in the same way how human did it, like a visual format, okay. So we will try to solve this in a visual format and then apply some rule based approach to classify the problem, okay, to classify the label. So before that, we have to know how image is represented in a computer system, right? How image is represented. It is represented using something called as matrix, having rows and columns, okay. So each image is a matrix having value. Each value represents a pixel value, right? And each value ranges from 0 to 255 for 8-bit image, okay. This is for 8-bit image. We can see here. So this is the handwritten image of 1, and in the matrix format, the computer will see in this format, okay. So wherever there is nothing, it is represented as 0, and wherever we have the darker or the black representation, which is this, this is represented using some value, okay, which is 0.6, 0.8, whatever. So this represents a image 1, okay. So this is how the image is represented inside a computer. So in case of MNIST dataset, each image has 28 cross 28. We can say 28 rows and 28 columns, which is resolution of the image, right? We usually say what is the resolution of the display, right? So that means the resolution is 28 rows and 28 columns, right? Usually the full HD display, they say, right? Full HD display, they say 920 cross 1080, right? These are nothing but a pixel values. 1920 rows, 1080 columns, right? This is the full HD standard resolution, right? So that's the same way image is also represented, okay. Now, as I said, we will be solving this using visual approach. What I mean by that is, let's say you have a point, okay, which has x coordinate which is 10 and y coordinate which is also 10, right? When you try to plot that on a 2D Cartesian coordinate system, you will see you will have y coordinate and x coordinate here, right? So 0 to 10, so here we have to have point x value of the p, which is 10, and from here we will have the y coordinate which is 10 as well. So that is why we can that is how we can able to plot a point p, correct? So similarly, if we have an image like this which is 28 cross 28, we have to reduce or convert that image to 1 cross 2. So a point p which we already saw, right, 10 cross 10 comma 10, we can say that 10 is x value and another y value is also 10, right? We can represent the same point in matrix format like this. The matrix here is 1 cross 2, or we can also say this is a row vector, okay. Will not go into details, but yeah, you can see we have to reduce the dimensions from 28 cross 28 to 1 cross 2, so that we can able to plot that onto a 2D graph, right? We saw that we are having 10 cross 10. So this is how we have to plot, reduce the image. So there should be a technique, right? That technique is called dimensionality reduction technique, okay. So there is a good block where they already reduce the dimension and try to simulate it. Let's go to that blog and see how that is working. So this is the block. Let's try to run it. So here you can see there is some groups emerging, right? So you can see the red color groups are appearing closer to each other as time passing, right? So the same way the green color, the light green color is also forming some kind of group. There is this purple color and also this goldish brown color, right? So all these are different labels or different numbers inside that MNIST dataset, okay. They have, what they did means they converted the images to 2D plane. So there are 70,000 images, right? They have reduced the resolution of that images to 1 cross 2, which is a point, and then they have plotted it, right? When they have plotted it and they have applied a y variable which is a legend, so they can clearly see the similarly appearing images are coming together and forming some kind of group, okay. So see here you can see this light green color appears to be 2, and here we can see the red color is zeros, and here you can see the purple color is 8. So you can see it's still running. So once this is completed, there will be clear groups for each label, each number, okay. So let's go back to the board. So they have used a technique called TSNE, which is called TSNE. So they have used TSNE technique, which is dimensionality reduction technique, to convert each image
which image means we have 70,000 images, right, in the data set. So they have converted all 70,000 images and represented that images in a point format having x and y coordinates. So each images were converted and they tried to plot it on a 2D graph, and then they have applied the legend, and then shockingly we can see these are the groups after applying the t-SNE and then having the legend on it, right? So I think red color belongs to 0. So here you can see this is 0, this is 6, similarly this is I believe 4. So these are the groups which have formed even though we reduced from 20 cross 28 to 1 cross 2. The information loss, there should be information loss because we are converting or we are reducing the size of images, right? When we reduce the size of images, the quality of the images will be gone, right? So the same way here also, when we reduced it using some dimensionality reduction technique, there should be some reduction in the information, right? But here the t-SNE has really performed very well, and also you can see the groups are really distinguished, right? You can see these are different groups, right? Now we can say this green color belongs to number 4, this blue color belongs to number 6, this red color belongs to number 0, right? So these are all 70,000 points plotted onto a 2D graph after converting using t-SNE, right? Now how can we classify, right? We can't just say that okay, this group belongs to 4, but how you will classify? Let's say tomorrow if some new point comes, okay, this is the query point or a new point. Now which group it belongs to? Right now you can visually see and say okay, it is inside the this group, so we can say it is as a number 4. But how you will do that technically or programmatically, right? So let's see that. Okay, so let's use x and y coordinate. Okay, this is one group, right? I try to classify these. I'll try to put a borders to it, and then we'll try to see how we can classify that point, new point, which is query point q, how we will classify that. So now in order to classify point which is q, we have to say, if again we are following the rule based approach, that's why I said we'll go by visually doing this and then applying some rule based approach, right? Right now we are in the second stage where we are trying to use some rule based or programmatical approach to solve this. So now we can say if x is less than x1, which is this point, and y less than y1, which is this point, okay, this is y1, we can say the query point will be, you can say the query or the point will be, then the point, we can say point is 4, okay, or the image is 4, because image were converted to points, right? We can interchangeably say image and point, okay. So this is one criteria, okay, and let's say another. So now if the q lies between these points, then it will be tagged as or labeled as 4, okay. Now let's try to see another example. Let's say there is new point which is this one, which is q1. Now how we will classify this? Okay, let's try to draw again. I think here is the group. So let's say this is y2 and let's say this is x0, okay. Now for the point q1, how we will do that? If x is in between, if x is less than x0 and y is between y1 and y2, then the image or that particular point is, what is the this golden brown color, is 1, it is 1, okay. So this is 1, sorry, 1 second. The point will belongs to 1. Okay, so that is how we can classify. Okay, will be some misclassifications. That's okay, because no ML system is perfect. The task of any ML problem or ML system is to make the accuracy as 100%, but we can't really say, okay, our ML system is 100% accurate. Okay, so that is how we can able to solve this using, first is visually solving this by using reduction technique, and then applying some rule based approach to classify the points. Okay, now one second. So now that we understood how we have solved this using machine learning approach, so at the end what we did was, we given an input X to a ML machine learning model. So the machine learning model should learn some function. Okay, here it is t-SNE. The t-SNE has learned something, so which is represented using f of x to predict the output, right? So given an input, there should be some way to apply the function which is called machine learning model. So machine learning models are considered as f of x to predict the output as y. So this is the representation of the ML problem. Okay,
now function f of x is very simple to understand. Let's take a simple problem. You have x values which is input, okay, and y values which is output. Okay, you have 6, let's say the answer is 36. You have to predict 36. From 7 you have to predict 49. Let's say 9 you want to predict 81. So you know the relation, right? So here we are just doing 6 multiplied by 6, or 6 square becomes 36. Similarly 7 square becomes 49, 9 square becomes 81. So the f of x here becomes, right, f of x becomes a square, x square. So now we are trying to learn from the data itself, right? So that is what I said. So you are trying to intelligently learn from the data to represent the output y, right? So that is what f of x means, right? I hope you have understood what is machine learning, why machine learning exists in the first place, and how machine solves the simple data problem, which is MNIST image problem, image recognition problem, right? So there are multiple different types of machine learning problems. Okay, right now what we saw was supervised, there is unsupervised. So supervised machine learning, unsupervised machine learning, and there is reinforcement learning. So these are different types of machine learning techniques. So just simply understand that whatever we saw is supervised. That means we have both input as well as output, which is y, right? So this is supervised. So when we don't have or when we only have x values but no y values, so there is no y values, that becomes unsupervised. Okay, so we will see all this in bit more clear in the future videos, because all these are on together a big topics, big chapters. Okay, there are multiple algorithms for each of these techniques, right? So we will see all this in the future videos. For now, if you have any doubts, you can comment down. I will try to answer them. So till then, thanks for watching and stay blessed. Thank you.